Example 10.14. We have a uniform rod of length L and mass M is free to rotate on a frictionless pin. We have a pin, we have an axis passing through one end. Let's say at the end, at the point O. The rod is released from rest in the horizontal position. At this position, we released the object with V initial equals to O and omega initial equals to O. I want to find the angular speed when it reaches its lowest position. I want to find omega final at this position. Okay? Let me explain 2 points. First of all, we have here T initial and T final. At initial time, we have omega initial and alpha initial, and any point on the road here has the same omega and the same alpha. For example, if I take here a point A or I take a point B, we can say VA equals to RA omega initial and VB equals to RB omega initial. As you see, when we have a rotation, B will move like this and A will move like this. Okay, this is about the initial position. At T final, we have omega final, alpha final. So VA prime equals to R A times omega final, and VB prime equals to RB omega final. Okay, the second point. You know, if I ask you in general to calculate, for example, omega or V, I advise you to use the conservation of mechanical energy equals to O. If I ask you to calculate, for example, the acceleration or alpha, I advise you to talk about summation of tau or summation of f. Okay, it depends the problem. This is in general case. In general case, maybe you can use delta mechanical to calculate A. Okay, you have to solve many examples to distinguish between to know which solution you can use. Anyway, we come back to the problem. Here, the initial position, initially, we don't have V, we don't have omega. And I tell you, I need to calculate omega final. So as we have to find omega and V, we can say for this system, we have a conservation of mechanical energy, delta mechanical equals to O. So mechanical initial equals to mechanical final. We can say initially we have kinetic initial plus potential initial equals to kinetic final plus potential final. Initially, we don't have velocity, so kinetic equals to O. What about the potential? Listen, in the case of a long object like this one, or any object, for example, if we have this one, and here we have axis, and the object will I release the object, will move down. Okay, here about the potential energy, you have to talk only about the center of mass. initially the center is here, and finally the center will move down to get the final position. Okay, this is the final position of the center of mass. You have to say the potential energy will be between the initial position of the center of mass and the final position. So the height will be h. Here we have h. So initially the center of mass has a potential, or the system has a potential mgh, and finally the system has a potential equal mg times 0, because we don't have a height of the center of mass. So in this case, we talk about the center of mass. We come back to this problem. Initially, here we have the center of mass, and finally is here. Okay, we can say here is the center of mass. We put the reference between the initial and final. The height will be from this point to this point. And you know, this height is equals to L over 2 from here to here. Okay, which is equal to L over 2. Okay, so the initial potential will be mg, or we can say mg times L over 2. We have only one object, equals. At the final position, here in this system, we have only a rotational motion. It's a so the kinetic energy rotational equals to I over 2 omega square. If we have a translational motion, kinetic energy translation equals to half mv square. If we have rotation plus translation, the kinetic, we have kinetic rotation plus kinetic translation. Okay, how you can know? Here, as you see, we have a fixed point as a point O. So we have only a rotation. In the case of translation, all the system will move away. Okay, will move away. In the case of rotation and translation, the system will move away. In the same time, we have rotation. Okay, in this case, we have only rotation. So the kinetic energy equals to half I omega square plus, what about the potential energy final equal to 0, because the center of mass is at the reference equal to 0. Okay, now we have to calculate I. As you see, we have I. Here we have a rod, and the axis is here. You know, I equals to ICM plus MD square. ICM is given, and D is the distance between the center of mass and the axis, which is equal to L over 2. Okay, so we can put its value mg L over 2 equals to, okay, here I need to calculate omega at the final position. We can say omega square equals to, we can eliminate 2 and 2 equals to mgl divided by I. Okay, so equals to mgl divided by I. I equals to ICM. I give you the value of ICM equals to 1 over 12. Okay, ICM equals to 1 over 12 ml square. So 1 over 12 ml square plus m times d square. D equals to L over 2 square. Okay. Now we have to calculate this value. We can eliminate m, and m. We have GL divided by L square divided by 12 plus L square divided by 4. So here omega square equals to GL 12 L square plus 3 L square equals to GL divided by 4 L square times 12 equals to 3G divided by L. So we can calculate omega, which is equal to radical 3G divided by L. So I calculated the angular velocity at the lowest point. Here omega equals to radical 3G divided by L. Here I ask you to determine the tangential speed of the center of mass and the tangential speed of the lowest point on the road when it's in the vertical position. So I want to calculate V tangential and let's see. Okay. I want to calculate the tangential speed of the center of mass. First of all, V tangent of the center of mass and V tangent of the lowest point on the road. It means at this position, it means the point A. Okay, here we have the point A in the initial position, and here we have the point A at the final position. Here we have the center of mass in the initial position, and here we have the center of mass in the final position. I need to calculate the velocity. You know, here initially we don't have velocity, and at the final position, as we have a circular rotation like this, okay, V at the point A must be tangent to the trajectory, as we see. At this point, it must be tangent. At this point is tangent. I need to calculate V at the lowest point in the vertical position. I mean at this position. We have to find V of A. Okay, V of A. And also at this position, I need to find VCM. Okay, VCM and VA. Okay, let's take first of all VA. VA has a trajectory around the x at the point O. You know, VA equals to RA times omega final. Okay, and V of the center of mass equals to R of the center of mass times omega final. We have the same omega with a different radius. So we have a different velocity. We come here to see the radius of A is from the point A and the x, this one, or this one. This one is the radius, okay? Which is equal to L, the total L. So we can write VA equals to L times omega final equals to 3G divided by L. We get, finally, we can put L inside. Here we get 3G divided by L times L square equals to 3GL. Okay, what about VCM? VCM has a rotation like this around the axis with a radius equals to L over 2. Okay, this is the radius. So omega of the center of mass, or V of the center of mass, equals to L over 2 times omega final, which is equal to L over 2 radical 3G divided by L. We can put inside L square divided by 4. We get 3G divided by 4L. This is the value of VCM. So we get here VA equals to radical 3GL, and V of the center of mass equals to 3 divided by 4GL. Okay. Now, this is about VCM and VA. Here, maybe I can ask you about the acceleration A of the point A and alpha. If I tell you find alpha, just I need to give you the position. Okay, we have only alpha initial or alpha final. You know, alpha of A initial equals to alpha of the center of mass initial equals to alpha initial. All the points on the road have the same angular acceleration initial, and also all the points have the same angular acceleration final at the final point. But when I say A or omega, A or V, we have to precise the position and the point. Okay, so for alpha and omega, I need only to precise the position. Only. For each position, we have alpha and omega. At time t initial, we have alpha initial and omega initial. At time t final, t1, t2, we have alpha 2, omega 2. But when we talk about A and V, you have to precise, first of all, the position. Second, we have to precise the point. Okay? I mean, at initial position, we have A initial. For which point? For the point A. At this position initial, we have V initial to the point A. And also we have A initial for the center of mass. And we have V initial of the center of mass. It means you have to precise the position and the point to find A and V. Okay,